Everybody here? As our next speaker, I'd like to introduce Bas Moorkens, but I don't think that Bas needs an introduction for most of us. I think at AWS, they are thinking about inventing new certificates so that Bas can get another certificate. But anyway, Bas will tell us about his experience in AWS and how to scale it from an easy POC to enterprise level software. So the floor is yours, Bas.
Thank you. Thanks. So I guess we're going to do this in English. Okay. Nah, that's going to be a problem.
Yeah, we can ask, are there any non-Dutch speaking? Is er iemand die geen Nederlands praat?
Nah, but I did prepare it in English, so. But I might occasionally start rambling in Dutch about stuff that frustrates me. So, AWS in the enterprise. Who am I and why would you listen to me? Yeah, Peter already gave this explanation, but I'm going to do it again. I like to pat myself on the back. So I'm Bas, worked for Adena for a while, so you might recognize me. I've been using AWS since 2016. I did build and operate a lot of home projects on it because I found it pretty interesting. And I've been using it professionally since around 2017. I've had various roles and positions, all very nice titles, but it was mostly on the infrastructure part of things, which is cool, but I'm going to talk about that. And also, the architecting part was really interesting, and there's a lot of influence in this talk from that. And also, the last point, I have to make a bit of reclam. I'm part of the AWS Community Builder program, which is an AWS-driven program. So if you're presenting or blogging or doing workshops about AWS, know that you can apply for this program, and the benefits are that you get some swag, a cap, a drinking bottle. You get free credits to tinker around with AWS, and you also get beta access to several new features in different services. So that's enough free advertising for them. What am I here to talk about? So I first wanted to do a tech story because, yeah, you know me, I like tinkering with details. But then I thought, yeah, it's already 5 o'clock once they see me, so people might fall asleep. So let's just do a story. So I'm here to talk about my journey with AWS, from the first time I built something to where we are today, running very large projects for a very large company. And along the way, I'm going to touch upon some points that I think are good pointers, lessons that I had to learn the hard way, or sometimes the easy way, to get some best practices. And one thing to remark, this is how I experienced it. So this is not a silver bullet or anything. So if you start doing stuff I'm here to talk about and it backfires, don't come to me. So, my first baby steps in AWS, back in 2016, I was doing a lot of PHP programming. And I heard about the cloud and it sounded cool, so I thought, hey, let's run a website on AWS. So I got started and I made a web server with Apache, and I did a GitLab server and a Jenkins server because those are all such cool topics. And this was all fun to get started and to discover it a bit. But I found out pretty quick that managing EC2 servers is pretty, how do I say this? Not cool. It's a lot of hassle. You have to patch those things, make sure you configure them right. So this is the first lesson that I want to share. If you are running everything on EC2, you're probably doing it wrong. And you can trust me on this one. So if you're working in an enterprise and you're just lift and shifting stuff to the cloud on EC2, don't do that. It's going to backfire seriously. And back in the time, there were a lot of talk going around at the place I worked about cloud native development. And I was first like, what is that? But soon I discovered that's all about the good stuff we're using hopefully every day now. Huh? Docker, Kubernetes, serverless, Lambda. So I was thinking, maybe we can do it better. But in 2017, when we were first talking about these things, there were still some issues with it. Like, for example, okay, wrong button. EKS, so the managed Kubernetes on Amazon, didn't exist yet. So if you wanted to do Kubernetes on Amazon, you could do it in the hard way, like the manual does, with kubeadm. And yeah, that's a pretty shitty deal. There were Docker containers available, ECS, but it's pretty proprietary. And to be honest, if you start with it, it's a bit funky how it works. So also, and back then Lambda and the serverless movement was still up and coming. So Lambda had a lot of limitations back then, stuff that, thank God, is gone now, memory limits, runtime limits. It's increased a lot. But this was also not really a good candidate to really start building your production stuff in yet. And on top of all this, there were even more challenges. So if you do software development, not just tinkering with PHP at home, but you're really working in an organization, you probably don't want to have only one environment, which is prod, but you want to have dev, stage, QA, whatever you want. But you want separate environments so you can push development in a gradual way. Now, the question is, how do we do this in AWS? Because on-premise, yeah, you just had different servers probably. But yeah, in AWS, you could put different servers in one account. You could create multiple accounts, whatever you want. There was not really a lot of guidance back then around this. But spoiler alert, it's multiple accounts. But then that brings me to the next issue I was facing. If you start creating a lot of accounts in an enterprise organization, that's all fine. But there are some cross-account concerns, and that's just a fancy word to say, for example, you have a lot of legacy stuff on-prem, databases, applications, whatever. You probably want to access some of that data. How are you going to do that? Do you let the development team set up a VPN connection to on-prem? Do you create a direct connect with a dedicated line? The second part, you're now running in public cloud, and I heard some stories between the coffee already about nasty security fuck-ups. You're running in public cloud, so if you screw this up, yeah, you're gonna be caught with your pants down, and it's gonna look very nasty. Billing, another good topic. When I created my account, I added my credit card, and that was it. But if you have 100 accounts, yeah, what are you gonna do? Attach a credit card to each one? And last but not least, the access to the accounts itself. So most of you probably are familiar that you can log in with your Ordina login to everything, which is nice. But natively, that doesn't exist in Amazon. So you can use their IAM groups and users stuff, but then you start creating users and groups for every account. Also not very handy. So these were a lot of the challenges I was facing back then, but thankfully, I brought some solutions. So the first set of solutions is very simple. Some things just solve themselves, which is nice when it does that. So there was a lot of push to cloud native development and serverless in the last few years. I mean, EKS was released back in June 2018. So that all takes a lot of burden away from you. You don't have to manage everything anymore. The serverless framework, and I'm not talking about Lambda yet, but the framework as is got a lot of traction and adoption, and it's a really nice tool to set up these kind of setups. So I really an aanrader. And AWS Lambda got a lot more flexible, which also helps. Now you can let it run longer than 50 minutes and give it more than 2 CPUs or 4 gigabytes of RAM. I mean, if your Lambda really needs more, you're probably doing something wrong, but that's another discussion. Now, the other things I talked about, the cross-account stuff, that's not solved with this. But thankfully, AWS has some services for that. And I like to call these the enterprise services. So that's why I coined the term enterprise-grade AWS. And the first thing I want to briefly touch upon is AWS organizations. So I tried to draw a nice diagram, and it worked pretty nice. So you can see this is a representation of how an organization might look like. And at the top, you always have one master account, which pays the bills. So that's probably where you want to put Peter's credit card. And under that account, you have several OUs. An organizational unit, or OU, is just a logical container. It's not something tangible, but you can have an OU for your security team or for your core OU. You can have it for your separate development teams, and under those, you can start creating accounts. The reason why I'm drawing it this way is that it has some advantages to the things I talked about earlier. Like, organizations makes it very easy to manage all these accounts in a uniform way. So that's a big win for the people that need to manage that. You also get cross-account consolidated billing. So all the bills just bubble up to the top, to the master account. And in the master account, you have to pay the bill, but you get a lot of free reporting about who is making what costs, what services are used, what regions are used, stuff like that. And also not unimportant, but lesser known, AWS has this concept of volume discounts. So if you are running, say you're running 100 accounts, separate from each other, not in an organization, and all these accounts have a shit ton of servers, that's fine. But it's not very useful for you. If you are running all these servers in these accounts in one organization, AWS will look at you and say, hey, you're my buddy, you're paying us a lot, so you get discounts. So that's one of the nice things about this. And the second part, what goes hand in hand with organizations, is SSO, single sign-on. So I talked about the problem with all the IAM users that you have to create and maintain, which is not a nice way of doing things. But if you use organizations together with SSO, you can federate your existing AD setup. So what I mean by this is, say you have a Microsoft Active Directory server. For example, in Ordina, you might have an AD server with groups in it, a group for JWorks, a group for VisionWorks, whatever. And with SSO, you can bring this structure into the cloud, and there you can map it onto permission sets, which is just a coupling to a policy, and you can then map that to accounts. So it becomes very easy to say, for example, the JWorks group in our Ordina server has access to only the JWorks accounts in that OU. Or what I took a screenshot of in this case is, say we have a role Cloud Ops Administrator, so we don't want to maintain our stuff in prod, we give that to ops people. But these guys, they need admin access to all our accounts. So it's very easy to set it up with this SSO part. Now, the question then rises, who will set this up? Because, yeah, it's a pretty specific thing that you have to know. So do we give that to software engineers? Do we give that to infrastructure people who are probably still living in the 1990s with their servers? Do we give it to security? And this is how a cloud foundation team, specialized team, is usually born, out of a need to do these kind of things. Now, cloud infra teams, what I'm here to talk about, because I like patting myself on the back. I've worked in those teams for most of my career. I'm going to give a bit of explanation about that and why they are so awkwardly positioned in a company usually. So, what should you do in a team like this? Seems pretty easy. You should enable your software development teams to use the cloud for what they want to do with. So if you're building a product, you don't want to be bothered with security setups and networking setups and backups and all that shit. No. You just want to develop your business logic and a couple things around that. So in a cloud infra team, we're building foundation. We're laying the foundation for these product teams, and we try to build reusable components so that we build it for team A. For example, we build something to deploy Kubernetes, but that's going to be generally the same for every team that wants to use it. So we try to make it reusable. And we also try to implement cloud best practices, of course. So a large portion of the job is building landing zones. That's the term that's used for these kind of things, landing zones. When I first heard it, I was like, what? But it's just a term. Now, the thing with these landing zones is, and that's the real challenge for this cloud foundations team usually, is you're building a very diverse set of landing zones. So you need to have a very broad skill set in your team. You need to have some in-depth knowledge of AWS services, because otherwise you don't know the best practices. But you also need to have a very broad sense of how does networking work, how does DNS work, how does security work. So it's pretty hard to get these people together in one team. And to top that off, so you want this team to be close to infra, because in the end you're just spinning up infrastructure. But you also want them to be close to software engineering teams, because that's the people you're serving. So you have to know your customer a bit. And you probably, since we're going to talk about infrastructure as code, you want to use software engineering best practices to do that. So it's a very delicate balance that you have there. Now, about these landing zones, I briefly want to touch upon those. I kind of distinct them in two categories. So you have the foundational ones, which I already mentioned. These are components that you want enabled for your entire organization or in every account, no matter what. And then you have the consumer infrastructure, the consumer ones. And these are things that you as a software team can cherry pick. So you can choose to use them or you can choose to not use them. Some examples, I already touched upon this, organizations and SSO, on-prem connectivity, security stuff, cross-account roles, nothing too fancy. And for the consumer part, EKS, we're gonna take a closer look at that one because it's so interesting. And other examples are databases, CloudFront for website hosting, stuff like that. Now, I hear some of you already think, what's the advantage, Bas, of doing it this way? Because you have AWS, you have the console. I mean, isn't the whole value proposition that you can just go to this website and start clicking stuff together? And I'd say, yeah, that's true, but it's not a very repeatable setup. So why not? So the purpose is, if you have a dedicated team to create those things, you should be certain that the best practices are in there, that you're getting a repeatable piece of landing zone that other teams are also using. And it's just a tough job to really get all the details right if you're not working with those things every day. So, now what does a landing zone look like? Well, they're typically built in some infrastructure as a code framework. And I could say there are a lot of EAC frameworks, but let's be honest, Terraform is the industry standard, and we're probably not going to diverge from that anytime soon. So go Terraform. And a landing zone, and this is the important part, should be managed like a software application. So you want to have these things versioned, Terraform modules, you want to have them versioned, and preferably semantic versioning. You want them available in some central registry, and ideally, if you can, and this is not an easy part, you want to have them tested and published through CI/CD. So if you can achieve that, then you're basically working in the way that software engineering teams work, and that is a proven process. So it's a lot better than just cowboy styling it. So this is another diagram I drew up. Yeah, I love diagrams. It's a very simplified version of an AWS account, and I just wanted to show this because where I work now, Telenet, we can provision an entire account just through a pipeline by just selecting which landing zones we want. So it's a lot easier than having to piece everything together manually. And for example, we have an account landing zone which sets up some stuff. We have a network landing zone which does the VPC setup and the on-prem connectivity. We have the same thing for security. It's nice. If we use this pipeline, we know that every account looks the same, is set up in the same way, it's secured, it's compliant with security standards. So it makes it easier to maintain these things afterwards. Now, those are all examples of foundational landing zones, and I wanted to put one in for the consumer side. So this is how an EKS landing zone could look like. But as you can see, if we're looking at a real example, it gets a lot more complex than just me drawing some stuff. So I'm not gonna deep dive into that. But the main message that I want to give with this slide is setting up EKS, for example, is pretty complex. I mean, you can click it together and it will be up and running in 5 minutes. But a very good example of things that all teams struggle with the first time is if you log in as a user, you create a cluster, then that cluster is only available to you. So that kind of sucks if you want to work in a team. So if you have a landing zone that sets up all those federated roles, then that's settled for you once and for all, for every team that uses it. Now, the nice things about this way of working is, for the infra engineers, we can quickly provision stuff for our customers. If you come to me and say, I need an AWS account, I say, okay, let me run my pipeline and make some coffee. Nice. We are also sure, if you're using this, that the best practices and the guardrails that we put in place are respected. So that's also nice. And we can easily update this stuff. So if we decide that our VPC setup is outdated for whatever reason, we can just release version 2.0 of our module, and we can just upgrade it that way. Very easy, very nice to work with. And for the software engineers, this is probably more important. It makes it very easy for you to get started with AWS. And I know you can get started also in the console, but this way you get all the best practices and all the good stuff that comes with these complex setups. Of course, there are also drawbacks. Software engineers want to be free. That is my experience, at least. They always try to break stuff I built, so yeah, I'm not happy about that. And me, I don't want you to break stuff. I want things to be steady. Otherwise, I get called, and I'd have to come out of bed. I don't like that. So, okay. Aha, we're back. So where does the truth lay? Like in all things IT, it's somewhere in the middle. It's somewhere in the middle. So do you want to move fast? Do you want to have a very rigid process? It's somewhere in between. Now, how do you sell this concept to people? How do you get engineering teams to actually use it? Well, and this is pretty funny, because I was thinking about, first time, about a lot of very high-level arguments, but first of all, make people aware that these things exist. If engineers don't know it, they won't bother. So you can do demos and webinars and brown bag sessions to do kind of sales pitches. Huh? Very important first step. The second thing is be open for feedback. I mean, nobody likes it when we infra engineers build something, we throw it over the wall and have fun. It doesn't work like that. So be open for input from the engineers, from the software engineers. Ask them for feedback. And what you can even do, if when your organization matures a bit, make the code of your landing zones, because it's just code, Terraform. You can make this open on GitHub and be open for feedback through pull requests, for example. And another good pointer is help them get started. If you're coming from a very traditional way of working, Java on-prem with OpenShift or whatever crap these days, help them, teach them Terraform. You can do pair programming with them to set up the landing zones and share some advice on best practices. It works a lot better that way. So now for the main takeaway, because I think I've babbled long enough, and please don't fall out of your chairs. Skills can be taught. Huh? It's not that hard to get started with AWS. You can learn from it. There are a lot of good courses online. Experience can be gained. There are, in every organization, some people who are at least have some experience level with it. But, and now the grand conclusion, can I get a drum roll? A cloud journey in a company lives or dies by community. And no, this is not an agile talk, but I found it very important and I found it very tricky. And this is the final slide, what I'm gonna end with. The tricky part about this is, I talked a lot about the weird position of a foundational team in the organization. You're hovering around a bit. And if you're trying to build a community for your entire enterprise, you want this community to exist of a lot of different people. You want software engineers. You want the business, security, operations. I mean, everybody has a different point of view and a different value proposition, how they're going to get value from the cloud. So if you're setting up something like a center of excellence or whatever, you should have all these people on board. And once you figure that one out, please make sure to come and tell me, because that's what I'm still struggling with, how to do that. So, are there any questions?
We got the mic for that.
You mentioned that you can evolve the landing zones over time, but how do you make sure that that they are actually rolled out as well? Does your team do that, or does the feature team do that?
So in the organization I currently work for, we are maintaining the foundation of all. So that's code that lives on our side. And what we have done in Terraform, you can, the tilde operator, you can use that for the version. And then it will automatically upgrade minor versions, for example. So what we usually do is we use semantic versioning, major, minor, patch. And if we bring out minor versions, we assume that it's automatically safe to update. So we have pipelines running every night on GitLab. And all the modules have the tilde operator for it. So they will automatically upgrade minor versions during the night. Now, if you're doing a major release and you're following semantic versioning, you probably have breaking stuff. That's another story that you might want to do manually. But my philosophy is automate everything you can. I don't want to bother with upgrading Terraform. That's below my pay grade. So we do a semi-automatic process. Even in production accounts. So if your digicoder doesn't work, yeah, I'm sorry.
Where do you draw the line between what the cloud infrastructure team has to do and the software engineer team has to do? Because, for example, in our case, we had to set up a database on AWS, but for someone that has never touched AWS, it's probably hard to configure a database with all the necessary security principles that your company wants. So where do you draw the line between that personally?
Good question. Funny question, because that was the first thing I did on KBC, creating a module for a database. Well, I don't really have a golden truth for this. It kind of depends on the organization, I think. Where I work now at Telenet, we do a lot of stuff in the foundational team, stuff that shouldn't always necessarily be there. For example, databases, EKS. We provision that. But the tricky part about, for example, a database is I'm no DBA either. Yeah, I know how you connect to one and some best practices like encrypt the volumes and stuff like that. But it's even hard in a foundational team. Now, for a software engineering team, yeah, you already said it, it's going to be even harder because you're missing those best practices probably as well. So how I see it, and this is purely how I see it, it should be a collaboration, preferably between the DBA team and an infrastructure team, and potentially even software engineers. That's what I was talking about earlier. The more you put these people together, the better your module is going to be, and the more your consumer will be happy to use it. Because if you build something crap from your ivory tower, I've been there on the other side. I know how it goes. So, yeah, it's a hard question to answer. But I think it's a lot of dependent on the organization that you're in and how they are set up, how mature they are already. Maybe your software engineering team has been doing AWS applications for 10 years, and yeah, who am I to say something then? So it depends. Sorry.
Do you have any automated testing for your infrastructure modules or whatever? Or you just say, oh, this will work probably, and you just deploy it once, and then, and do you have any like smoke tests that gives like alerts? And do you have a fallback or rollback scenario when it doesn't work?
Yeah. So when I was talking about the software engineering best practices for the module, for the landing zones, I said preferably you have a pipeline that automatically tests it and pushes it to the registry. And right now we push it to a registry, but there is no testing on it. No automatic testing, because I have been involved in cases to try and set this up. I forgot the name. There is a framework to test Terraform stuff. TerraGrunt, TerraTest. Yeah, that's it. But it's kind of hard to get right, because how can you test Terraform? There is only one way that I know of. Actually run it and see if the infrastructure that was spun up matches what you expect. But it's pretty cumbersome. It's not like when you're doing Java code, you have unit tests and integrate. You can mock stuff that all doesn't exist here. So it's spin everything up and somehow check that everything is according to plan. So that's something that could use a lot of improvement. Not only for my organ, but in a general, because I'm not aware of any better solutions right now. But it's something a very good remark.
If you want to roll back, how would you do that? If you want to recover from something that went horribly wrong, are there any strategies to do that in an easy way, instead of doing it, checking what happened and then just trying to make the best out of it?
Yeah, if stuff really gets if stuff goes really wrong, we can hard lock our modules to an earlier version. So we usually roll back in that way. But yeah, then we're manually intervening. That there is no automatic detection because there are some pretty complex systems. And the added fun factor that we struggle with a bit is, so to circle back to the EKS example, we have a module which works nice. We throw it over the wall to software engineering teams, high five, everybody happy. But then, because we did not educate them enough, people start messing in the UI with stuff on the cluster. So for example, certain people, certain teams gave a certain AWS user rights to access the cluster to do deployments in prod. But if we upgrade our module and it runs, Terraform sees, this trust relationship doesn't belong here. Bye-bye. And then prod is not okay. So in an ideal scenario, you have aligned this with everybody to always do everything, because once you start mixing these stuff, that's when you get in real nasty situations. Because we from our side were not aware that that thing even existed, so we're like, we didn't do anything, and they're like, no, it broke. No. So it's a lot of manual searching, sadly. But hey, sometimes I even have to work a bit.
Where do you store the Terraform state for those landing zones for those accounts?
It's in S3 buckets.
And in the same account as for which you roll it out, or in the central?
No. So I'll share a bit about how our organization looks. We have our master account which pays the bills, but we also have a separate OU where our cloud infra accounts are stored. And in the cloud infra account or production account, we basically have the state files for all the other accounts, but just for the foundational stuff. So we give you an account. It has all the foundations like security, VPC, whatever. If you then come to us and say, hey, I want to run stuff on EKS, then we help you set up the EKS module in your account, but you own that module, or that's the philosophy that we're trying to implement anyways. So that stuff will live in an S3 bucket in your account, but we do provide access to teams upon request to our state files. You can access them through a very large set of hoops and jumps through remote state files. So we do that on demand, because we don't want every team just don't put your hands in my state files.
Yeah, what's the best practice to give one AWS account access to another one? Like the best practice for one AWS account to give access to another AWS account?
It depends. What kind of access are you?
Like a Lambda? Or
like a Lambda, there are a lot of ways to do it. In the example of a Lambda function, say you're exposing it through API gateway, you could write an authorizer or just use Cognito. If you use, for example, Cognito to do it, you can create cross-account roles. So I can create a role in account A that is trusted by account B to do certain actions in that account. That's generally how it's going to work in the case of Lambda.
Okay.
Well, whatever you do, don't share access keys.
Any more questions? No, I'd like to thank Bas for the nice explanation and a round of applause, of course.
Thanks.